Dear students, grade 12. As you know, we have finished the chapter of Equilibria, and before we go to the next chapter, this is revising the Equilibria chapter, and this is video number 1. Just as a reminder, we know that there are two types of acids and bases. There are strong acids and bases, and there are weak acids and bases. For strong acids and bases, completely ionize or dissociate in dilute aqueous solution. Aqueous solution means aqua is a Latin word for water. Strong acid, strong soluble bases, and most of their salts are also soluble. This is an example of a strong acid, hydrochloric acid. When it reacts with water, it completely turns into hydronium ion, which we can say just H, and chlorine, negative ion. This is potassium hydroxide, which is a very strong base as well, and in water also it completely dissociates to potassium, positive ion, and hydroxyl ion. Now to the concentration of ions. To calculate the concentration of ions, here, calculate directly from molarity. Molarity means concentration of strong electrolyte or the strong acid or base. What is the concentration of hydrogen ion in 0.25 molar of HCl? Okay, so this is one question, and this is the answer. Okay, if you think of HCl, HCl actually is a strong acid. Okay, so instead of electrolyte, electrolyte can be acid or base, and we say they are electrolyte because they can dissociate and also they can conduct electricity. And this part we will come to study it in the next chapter more elaborating. So acid or base, especially strong acid or base, because they completely dissociate or completely ionize. So the question again, what is the concentration of hydrogen ion in 0.25 molar? Molar means the concentration, which is mole per diameter cube HCl solution. So to start solving that solution, you have to think of, this is the main thing, the HCl. HCl is a strong acid. This means that it completely dissociates into positive and negative ions. So HCl dissociate into hydrogen and chlorine. Okay, for starters, he said that in the question, he said that the concentration of HCl is 0.25. So this is the initial concentration of HCl. So in this case, at the initial, before any reaction happens, this means that here is 0 and here is 0 molar and here is also 0 molar. And then as the reaction happens, or as you add the HCl into an aqueous solution, whether it's water or something else, the HCl actually, which is the reactant, we know that the concentration decreases because the reaction is going on, and the products, their concentration increase. And since you know that HCl is a strong acid and it's completely going to ionize, so after that, at the end of the reaction, so here is minus 0.25 and here it increases with the same amount that the reactants decrease. So at the end of the reaction, there will be no HCl because it completely ionized, and the concentration will be the concentration of the hydrogen as well as the chlorine. Correct? So the concentration of hydrogen in this case is the same concentration of the HCl because it's a strong acid, right? Okay, here is another question. Calculate directly the molarity of the strong electrolyte. In this case, actually, it's barium hydroxide, which is base. Here's the question. There's your question. What is the concentration of hydroxide ion in 0.25 molar barium hydroxide solution? Again, let's start with the table. Our main point is barium hydroxide, BaOH2. So when you add it into an aqueous solution, it completely also ionizes because it's a strong base. So here we have the initial concentration. The initial concentration is only for the reactants because nothing happened yet. There is no reaction. So as well for barium ion and hydroxyl ion, it's 0. The change happened here. The change happened, the barium hydroxide actually decreased, right? And the barium ion increased by the same amount. Also the OH. As you can see here, after you balance, and this has to be balanced, you have 2 OH here. You have 2 OH. So you have to multiply the amount of concentration for 1 hydroxyl into 2 because you have 2 moles of hydroxyl group, right? And at the end of the reaction, here's what happens. At the end of the reaction, as usual, the concentration of barium hydroxide is 0 because completely, yes, ionized in the solution. And the barium ion has the same concentration of the base, the main base. And the concentration of hydroxide actually is double because you have 2 moles of OH. Okay, that was easy. Just calculating the concentration of hydrogen and concentration of hydroxide for strong acids and base because they completely ionize, so they carry the same concentration as their strong acid or strong bases. And of course, you have to be careful. First, balance the equation, okay? The equation of dissociation. Now for weak acids and bases. How do you know that they are weak? They slightly ionize in dilute aqueous solutions, means they do not completely ionize. So in the solution, when you add a weak acid or a weak base, you will find 3 things or 3 particles. You will find positive ions, negative ions, and molecules. So you have weak acids, weak base, and a few covalent salts. Covalent salts means they also do not completely ionize. Now, the autoionization of water. Also, we studied that water is considered amphoteric substance, means it reacts as acid and reacts as base. And water actually completely ionized, not completely ionized, actually it's partially ionized. It turns to hydronium ion and hydroxide. And that we use to write it when we try to understand the organic equations or some of the chemical equations. We always write water as HOH. Okay? So this is the equation of water ionization. We call it Kw. Kw is the dissociation constant of water. The dissociation constant of water is the product of the concentration of hydrogen ion. This is hydronium and also can be written as hydrogen, and by the OH hydroxyl or the concentration of hydroxide. Okay, remember that equation, the Ka or the dissociation constant. We used to write the concentration of the products divided by the concentration of the reactants. But in here, there is no concentration of H2O. There is nothing. Okay, that's my question. Why is there no concentration? Why the products are not there? And it's the same rule. We're not using the concentration of H2O, considered it's a constant. Okay, so it's not written, considered it's a constant or 1. Okay, the autoionization of water. This is the particle of water. This is how it looks. You studied that in grade 11. It's a covalent compound. Yes, and there. When you balance the equation, H2O plus H2O, 3/4 of hydronium plus OH. You also learned that Kw is a constant amount, means the product of hydronium ion by the hydroxide concentration, the hydronium concentration by the hydroxide concentration equals 1 times 10 power of minus 14 at standard conditions, which is, or standard room temperature, which is 25 Celsius. So in this case means Kw equal 1 times 10 power of minus 14, right? So also means that the concentration of hydrogen equal to the concentration of OH, right? And both of them should be at equilibrium or at neutralization. Both of them should be 10 power of minus 7. For example, this is water. In neutral solution, there, the hydronium ion is equal to the hydroxide or hydroxyl ion equals 10 power of minus 4. See? As an example for that, water. Water is neutral, and in neutral water you have the concentration of hydronium, or the concentration of hydrogen is equal to the concentration of hydroxide. And both of them have the concentration of 1 times 10 power of minus 7 molar, or mole per diameter cube. There. For example, if you want to determine the concentration of hydroxide in water, so Kw, we know that it's constant, it's always 1 times 10 power of minus 14. And you have the concentration of hydrogen, which is 1 times the 10 power of minus 5. That's easy. Okay, so the concentration of hydroxide equal Kw, there. Concentration of hydroxide equal Kw divided by concentration of hydronium, right? There. So this means 1 times 10 power of minus 14 divided by 1 times 10 power of minus 5. Just, that dividing the indices just means subtract them. So it's the concentration of hydroxide is 1 times 10 power of minus 9 molar. Now, calculate the concentration of hydronium and OH in 0.05 molar of hydrochloric acid. This is your homework, and I think this is a very easy question to make. And hope you study well and staying safe, and hope to see you soon.